224, this is the reaction type and activity series quiz. On the front, the instructions say, name the type of reaction, predict the products, balance the equation. Please note that it does not say predict if the reaction will occur. Some of you are really excited about activity series, and that's wonderful. Number one, you are currently unqualified to determine if a reaction will occur in double displacement. You don't have enough information for that. You will when we do chapter 14 or 15. I think it's 14. You'll know how to do that, but you don't yet. And for the single replacement, yes, you're right. Ammonium fluoride plus chlorine gas would not run. But for right now, let's just practice the predicting. And I will try to make sure that if you are obsessive about the activity series, that I write my single replacements on the test so that they will all run and nobody feels itchy about that, if you're prone to feeling itchy. But, okay, so for our first one, we have, it's a double replacement. We have LiNO3, lithium nitrate, and we have NaCl, sodium chloride. And the first thing we want to know is what kind of reaction this could possibly be. Well, there's really only one option. This is double replacement. Everybody's going to swap dance partners. We'll end up with lithium chloride and sodium nitrate. Okay. So those are our products. It's already balanced as is, and it is double replacement. You can say double displacement. That's acceptable as well. My writing is really bad with this particular stylus. My apologies. Most people got that. That was pretty easy. That was a good one. Number two, you're given Fe2O3, iron oxide. You only have one reactant. Anytime you only have one reactant, there's only one kind of reaction that can happen. Decomposition. Yeah. So this is a decomposition reaction. You don't have to write reaction. You can just write decomposition. What is that going to break up into? Well, it's going to break up into iron and oxygen. Iron on its own is just Fe. Don't fall prey to putting a subscript there. Remember, if it's pure iron, it's just Fe. Oxygen on its own is O2. So then you have to balance that. And a lot of people want to make that Fe2, Fe2 plus O3. You can't do that. You have to handle those reactants as their own thing and write correct formulas for them. So this balances as 2 Fe2O3 yields 4 iron and 3 O2, 3 oxygens. Okay? Most people got that that was decomp, and the big problem, the big pitfall people fell into on that was writing the Fe2, and that's what happens every year. So if you did that, you have waves of former chemistry students behind you who no longer make that mistake. So you won't either soon. Okay. Number 3, this was a single replacement. And yes, this is one that you could predict using activity series, but we were not doing that. So a few of you, like I said, really do love activity series, and that's wonderful. If this did run, what you would generate would be ammonium chloride and fluorine gas. It's single replacement or single displacement. And to balance, it's 2 NH4F plus Cl2 yields 2 ammonia chloride and a fluoride. Okay. Number 4, there's only one thing to do with this. So number 4 is interesting, and one person got something that nobody else did. So there are two things coming together. There's only one product that we can possibly form, and that's magnesium oxide. And you have to remember the charges on magnesium and oxygen and write a correct formula. So we have that. To balance it, it's going to be 2 magnesium plus oxygen O2 yields 2 magnesium oxide. Remember how I said some reactions can be more than one kind of reaction? Well, the first thing that comes to mind with this, okay, we've got 2 reactants in one product. It's a synthesis reaction, right? Well, it's also combustion. Yeah. So maybe I had two people who put combustion. And it's one of those, it's not the kind of combustion we normally think of, but we are oxidizing something, forming an oxide. So it's both a synthesis and a combustion. Typically, I give credit for synthesis, and I forget. I think I've in the past I've done something similar like that, and you do have to identify that it's both. Now that we've talked about it extensively, okay. And the last one, we've got propane, C3H8 plus oxygen. We want to know what it's going to produce. There are only two products for a combustion reaction, and they are CO2 and H2O. Two products for the combustion of a hydrocarbon, I should say. Other combustion reactions have different products, but when you're combusting a hydrocarbon, if you're purely combusting it, the only things you get out are CO2 and water. This is, of course, combustion. Okay, and to balance this one, C3H8 5O2, whoops, yields, I got carried away there, 3 CO2 and 4 H2O. Okay. Questions, comments on the front? In terms of the imaginary points, there were 2 imaginary points per question, one for the type of reaction, one for the products and balancing. On a test, it would probably be a little bit more, because I'll give you, a point for predicting the products, a point for balancing it, or 2 for this, 2 for that. But okay. On the back, activity series. A, we have silver iodide and chlorine gas. So what would chlorine potentially replace? Iodine, the other halogen. And chlorine is more active than iodine, so what we're going to form is silver chloride, and we're going to form iodine gas, iodine vapor. So to balance, it's 2 of each of those. And that was your point for this one. On the test, I typically give a point or 2 points for saying that it will, and then 2 points for writing the products, and 2 points for balancing or something like that. I forget. Okay, for B, we have zinc chloride plus copper. What could the copper potentially replace? The zinc. And will it? No. Copper will not replace zinc. Zinc will replace copper, but copper will not replace zinc. So this is a no reaction. C, we have sodium chloride and bromine gas. What could the bromine potentially replace? The chlorine, right. And will it? No. So that's no reaction. D, we have aluminum fluoride mixed with iodine. What could the iodine potentially replace? Fluoride, because it's the other halogen, and it won't. Iodine is the least active of the halogens. It won't replace anything. Okay. We have sodium sulfate and lead. What could the lead potentially replace? Sodium. But sodium's very active. Sodium's way up on the list. Lead is way down on the list. Not going to happen. So no reaction occurs. Okay, so now F, we've got silver chloride, and we have copper. What could the copper potentially replace? Silver. And will it? Yes, copper is more active than silver. Silver is relatively inactive. So what we get out of that is, and a few people asked, hey, which copper ion is that? How do I know? You don't. So you can write a formula for either copper 1 chloride or copper 2 chloride. If you're predicting, you're not given, which ion is going to form. I tend, when given a situation like that, to write the one that allows me to not have to do any work to balance it. So that's my lazy way out. So I wrote that for copper 2 chloride. You could write it for copper 1, and then you'd have to balance, and you would have, what, AgCl2 plus Cu yields 2CuCl plus Ag. It's not that bad. So either of those is acceptable. Okay, for E, we have iron nitrate. Oops. Iron 2 nitrate, and we're putting that together with some zinc. What could the zinc potentially replace? The iron. And will it? Yes. Zinc is more active. So out of that we get zinc nitrate and iron. Okay? Those were each, on this they were just worth a point, so it was out of 17 imaginary points. Like I said, pretty big range of scores from, you know, a fair number hovering right around 10, a few up in the upper end, 15 and 16. So, questions, comments, concerns on any of these concepts? I'm here tonight for an hour. I do have physics kids coming in and I have chem kids coming in, but we'll make it work. Okay, you have time to work on homework.